Okay, sure, sir. So good afternoon once again to all of you. Sir, kindly proceed.
Nitin sir, can you see my screen?
Yes, sir. It is visible, sir.
Thank you. Good afternoon, ladies and gentlemen. I'm Dr. Anand Nayyar, and I'm working as professor and scientist in Graduate School, Dutan University, Da Nang, Vietnam. First of all, I'm very happy to be the part of this short-term training program. And I have seen this training program brochure, and it covers actually the most latest technologies. That is the hot point of discussion for research and even to undertake lots of problems for real-time critical applications. Really, it is a remarkable work done by the coordinators. I appreciate them. So today I will be discussing something with regard to the futuristic discussion on smart and autonomous vehicles, and even a technology that today, as a scientist, I would like to tell you that if it would have been originated 6 years back, we would have changed the face of the technology and the mankind of today. Still, this technology is on the early adoption, but you will all agree with me that this technology was required even before 6 to 7 years for better adoption and better manufacturing. So let me first of all introduce myself to give you some glimpse of my profile and how you can collaborate with me, what opportunities I have for you for collaboration. And then we start with session number 1 of transportation vehicles. So this is first of the glimpses of my photographs that you can see. On the left-hand side, you can see my photograph of Dev Day Da Nang. This is one of the best events in Vietnam. And last year, my presentation of IoT has received the Best Research and the Lecture Award. Here you can see my award as the Best Scientist Award and even the Best Researcher Award that I've got from the university. I am the first foreigner in 25 years of the history of my university that have got this award. And here is our robot, everybody, that is iRobot. That is actually being implemented at the Da Nang International Airport. So if you come to Da Nang, this robot will be the first to welcome you and to guide you that what is the weather, what are the hotels and accommodation facilities, what about the next flight schedules, the other things that you can place to visit. You can even book everything. So this is a connected interactive robot that we have already implemented in Da Nang Airport. And here is, you can see my smart owl, and this owl is so smart that it can just connect it to your home and it can automatically plug and play and even collaborate with all your devices. And even it can control your television. It can give you the air quality measurement, the temperature, humidity, what else you can expect. It is having limitless opportunities for the future smart homes. So that is the area that we actually do research, that we do on live areas and live implementations. So I'm working as professor and research scientist in Graduate School, Dutan University. I'm a PhD in computer science on sensor communications, swarm intelligence, and network simulation with more than 17 years of teaching and research experience. I'm specialized in almost everything that is sensors, manets, IoT, swarm intelligence, artificial intelligence, cloud computing, cybersecurity, brain computing, smart cities, transportation systems, and even flying ad hoc networks or drones. So I published 425 research papers, and out of which you can say that 121 papers are more than into SCI journals. So I'm having 50 plus articles on open source with 2600 plus citations on Google Scholar with H-index of 27 and I-index of 70. Even I'm acting as ACM Distinguished Speaker, and I'm associated with 1,000 conferences as National and International Review Board, Technical Advisory, Program Committee, Program Chair, and many more. So I have delivered more than 200 invited talks in 8 countries, 50 plus keynote talks, and 100 plus faculty development programs. And even I'm a certified drone pilot with 10 Australian patents, 3 Indian patents, which are granted, 2 copyrights. And I have been awarded with the 30 awards for teaching and research. And recently, you can see the top 2% scientist of +1 of 2019 index. You can see my grade at 89,545 rank. So let me first of all talk with my principles and mottos. So I believe in the first principle as knowledge for a better world. Now imagine everybody that knowledge and the information and even the technology that we see all around is not the technology that we have seen in last 3 years. It has actually improved with last 2 or 3 years, which has been improved. So the technology is going to change the face of future. So we have to keep ourselves updated. So don't think that you are a PhD or MTech, just keep yourself updated as a student of technology, because technology is dynamic, scalable, and highly flexible. Second, my motto is if you're stuck in some problem and nobody is supporting you, which already happens, so relax because God wants you to learn many things. So be relaxed and keep on working, keep on working, keep on trying. Maybe you can discover new things. And the third most important is don't be afraid of all challenges and hardships, because we are the technology people. We are the people who actually transforming the world. We are transforming the human beings. So that is the reason that the challenges will be all around us. So we don't have to be afraid of that. The only thing is we have to sit down, relax, calm down, and then we have to work step by step, and then we can find the solution to almost impossible problems in matter of fact of time. So for the collaboration opportunities, so if your student is a MTech student, so if he or she is interested to join under me for PhD computer science, they are most interested to join. So the eligibility is first class masters and even strong skill set in programming and willing to research with passion. And plus we see minimum 5 Scoopers papers or 2 SCI papers. But if you are interested for postdoc computer science, even you can join me as a postdoc computer science. And my specialization that I'm looking for is sensors, IoT, cloud computing, 5G, and even if you're working for big data analytics or cognitive radio ad hoc networks, or even you are working for that is called your smart cities and blockchain communications with AI technologies, I'm most welcome to take you as my student. So here is the postdoctoral fellow advertisement, and you can send me your teaching and research statement along with your resume, with your problem statement that what exactly you want to work. And maybe I will call you back for your, depending on the quality of research and the quality of research statement that you've given in front of me. So in order to apply, you have to give me a complete biodata with detailed resume, and we are only interested for your SCI and SCIE publications with no other publications. And we need your teaching and research statement, and we need top 10 publications in which you are actually working with only regular issues, because we all know, I'm talking publicly, so I'm not ashamed of this thing. We all know what is the frauds and what are the shortcomings of these special issues and what the bullshit work is going on these special issues. So we don't consider special issues, we consider only the regular issue publications. So research should be in the blood, and you should be willing to work 24/7, and you should have the strong skills in order to improve the solving of the solution. So I need a solution builder. I need a creative thinking person to work with me. So the agenda for today will be, we will be in session 1, we will be discussing autonomous vehicles and future transportation systems. I will be giving you a complete glimpse, like a complete course in next 1.5 hours. And after that, we will be discussing the future of digital twins. And believe me, everybody, both of these topics are hot areas. If you are researching on this, if you want to start research on this, this is the right time where you can get good amount of publications, and even good amount of research problems can be there. You can pick up and you can work on even real-time critical solutions. And even lots of funding agencies like Vine in China, we have Newton Fund in UK, Australian Research Council, they are looking for tons of grants on these 2 areas, specifically with, if you mix up AI in that. Of course, you have to mix AI in this. So it doesn't matter where you start, and the only thing is to begin. So let's begin the journey with presentation number 1, that is autonomous vehicles. So everybody, I would like all of you to kindly sit back, relax, and enjoy. And please keep on noting down important points on your pen and paper, because it is going to be a most miracle lecture for all of you, that what we can see in the near future, and I will be clearing all of your points. And don't hesitate to put your question on the chat box. You can put anytime. Once the lecture is over, I will be coming towards questions one by one. I will not wind up the lecture unless I complete the answers to all of your questions. So today we are starting towards the autonomous revolution of vehicles and transportation. Believe me, this is going to be the future. But today, why the future is uncertain, why we need to be prepared for this. The only thing is autonomous vehicles and flying vehicles are there in the world. But are we ready for that? Is autonomous vehicle technology word is actually happening today in 2021? That is what we have to see. Because don't think that if we have a flying car, we can start flying the car. You need to have more critical infrastructure that is operational at the back end and even at the front end in order to operate that car in real time. Okay. So let's start with the lecture in which I will be telling you converging technologies that is tackling the safety of autonomous vehicles. So I will be giving you the links side by side. You can see the links also. So the most important part of this lecture is to keep yourself aware that what is going to happen, what has happened, and what is happening, and what we can do for the near future. Okay. So let us talk the first of all with technology of transportation timeline. Let us see how we started from discovery of wheel and how we have come towards flying cars in 2020 and 2021. So you can see that the first wheeled vehicles we started in 3500 BC, and after that, after 1500 years, we have shifted towards horses. And horses were used till 1662, till we have the Blaise Pascal, who is also behind the basic foundation of computers, that is known as abacus. So he invented the first public bus, that is known as horse-drawn regular route schedule and fare system. In 1790s, the transportation got a new shape when we have the modern bicycles. In 1820, omnibuses. But the first revolution, like we have the French Revolution or Russian Revolution, it came in 1862 when we got the first gas engine automobiles. In 1871, we got the cable car, which we today known as subways or trams or even lorries or other things. In 1887, we got the subway system. 1897, the taxi cabs. And of course, in 2012, when we have Uber, we have Grab, we have other apps. Today, we can order like a taxi from one place to another. It all started. But still, let me tell you, from 2018 onwards, the work of automation has taken a crucial role towards transportation industry. And believe me, the next 4 years are very crucial, because what we are going to see, what we are going to innovate in next 4 years is going to be the future for the baseline, that how we can improve the mankind thinking towards transportation from one place to another. So that's the reason, everybody, today don't think of collaboration of technologies. Today, think of convergence of technologies. And let me tell you, today's modern vehicle is actually a global masterpiece, and even the brain, the power brain, that of any technologies that we can think of today. So today we have seen the transformations in mobility space. So if you talk of cloud computing today, I will be telling you how cloud computing is regarded as a major part of autonomous revolution after a couple of slides. So the most important thing is that we have to add one more important thing if we are talking of autonomous vehicles, that is known as mobility. So in cloud computing, if you mix this fusion called mobility and autonomous with cloud computing, we have mobility as a service. So you can see that today gas powered vehicles like with petrol, diesel, it is all shifting towards electric. And recently I came to know that Ratan Tata, that is Tata Motors, is also focusing, and they're investing millions of dollars in order to make the first electric vehicle car in India from Tata. So that is the main thing that we can see. But how digital twins will be able to support Tata Motors, I will be discussing in the next session. So now the human powered vehicles, when we are sitting on the driver's seat, I'm putting the clutch gear, and even I'm controlling the speed. I'm seeing everything on the eyes of the road. It is actually shifting towards autonomous things. So these are the two revolutions that we are saying: vehicles to electric, human beings to autonomous. So the safety is most important, and you can see that almost lots of accidents. These are only the reported numbers that I'm showing you right now, and even it's the old data, but the new data is not available to me. So you can see that 94% of the driving flaws or even the deaths on the road, it happens because of careless driving. And even you can say that 82% times on the highway, the truck drivers or maybe the bus drivers, they drive so rashly that they don't consider anybody as a human beings also. So pedestrians are also at risk, and even the commercial vehicles, they are increasing. Imagine the world when there was only few people that can afford the car, but imagine the world after 2 years when even a low middle class person can even afford the car. So imagine how much congestion and how much road safety concerns is actually required. So that's the reason it's the foundation that we actually require autonomous vehicles, when software brain takes a decision for how to drive, how to make the decisions, and how to transport the people from one place to another place. So autonomous vehicles will change the world. So let me tell you, everybody. So these are the three major pillars that is regarded as the foundation for autonomous vehicles. The first thing is called customer experience. Of course, it will save life. It creates money. It changes the lives of every one of us. Imagine that you are in your family and you want to chit chat with each other. You have a long distance. So don't need to worry that one person is busy driving on the road. You can just be with yourself, play the chess, play the games, play everything. Like in the car, like in the home, and the car will do the work autonomously. We have the broader disruption, we have the resetting towards the physical landscape, and of course, the reshaping of industries have already started. Consider Siemens, Audi, Mercedes, Waymo, everybody is doing the most important work. So business opportunity that we can see is known as the biggest opportunity since the creation of internet. And of course, it's a multi-trillion-dollar market that I will be showing you with the data that is going to support this lecture. And very significant improvements that we will see in short amount of time, because if you can talk of AI, it has revolutionized the world in last 2 years that we have not seen the word in last 22 years. So auto industry is one of the industry that is going to be the engineering marvel where every technology will be converged together, be it technological, be it social, and be it the regulations. So everything is coming under the one landscape. And believe me, it is an integrated view necessary to access the implications. And of course, in terms of technology, we have autonomous driving, social, we have the sharing of data, we have the communication systems, we have the advanced recommender systems, and of course, we require city regulations in order to keep safety and security of the pedestrians. And of course, data privacy is one of the most important concern for this type of car to handle. So Intel's road to autonomous driving, and you can see that Intel is one of the companies that actually conceived the idea that, of course, we can lead to autonomous driving. So you can see that they started with electromechanical safety when we have airbags, and even today we use airbags. If you press the brake very hard, or if you hit a person, or if you hit on the road, God should not keep this with any one of us. So still electromechanical safety is one of the basic safety. And after that, we shifted towards in-vehicle infotainment. Today, we all know that we have TV screens, we have a live TV, we have the live radio in the cars. We have the lane departure, blind spot, and of course, parking assistance. But in the near future, by 2021 itself, you can say that if you want to park something, the computer vision cameras will detect the place and automatically it will take over the control to park the vehicle in an autonomous fashion. So even it's a hand-pay-hard problem, but can be solved with deep learning algorithms. Of course, assistance with adaptive cruise control, emergency braking. But of course, the final destination of this vehicle is only known as self-driving vehicles. Then we have full control with the vehicle software brain. We are not even touching even a single control, or even the controls are not even present in the car. Everything will be done with the help of computers and AI chips. So autonomous driving progression, you can see that it actually started from 2015 when we have advanced driver assistance. But in 2018, when we have gone to supervised partial automation with advanced wireless communication, we all know 5G, but I'm not talking of 6G, but 5G plus, which means improvement towards 5G with better blockchain and AI technologies. And of course, to 2021 will be regarded as a high automation level with level 4, and by 2024 onwards we have the full automation level. So if you talk of the automation levels, we have the 5 automation levels. I will be telling you in the next slide. So these are the 5 automation levels: level 0, 1, 2, 3, and 4. So I will be telling you one by one. So these are the levels which are actually being regulated and by the National Highway Traffic Safety Administration. So let's talk of the level first of all. So level 0, that is known as 0 level. If you buy any car today without any automation, which means it's a simple car, you have to take over the entire control from driver, everything, that is 0 automation. And of course, we have level 1 when we have vehicle assistance to the driver, that okay, speed down, you can save a GPS, or you can have some parking assistance. Partial automation, when of course some acceleration features or even the driving features will be taken over by the car, which means you are driving, but still you can handle some of the features to the car. Conditional automation, when of course driver is not required to monitor the environment, and of course the car will take the decisions and give the recommendations, when the reinforcement learning will be actually being used. Now coming towards high automation and full automation, which is actually being the face of deep learning. So imagine everybody that when the vehicle is performing all the functions and you don't even require, and you don't even have to touch any control. Still the controls are there, but you don't have to touch the control. Like we have seen the cars in Men in Black, where the computers can even drive, but still man can even take over the control. But I'm talking of full automation, like the car is autonomously driving or flying, and there is no need to even have the controls on board in the car. So lots of benefits and cost problems that you can see, but you can see from the slide, I will not discuss much. I will just take the name. So driver stress, the cost of driving, safety, efficient parking, fuel efficiency, and of course the connectivity like the advanced vehicular ad hoc network or the flying ad hoc network will be there. But in terms of cost and problems, still we have additional risk in terms of privacy and security, but still the work is going on. Cost is very high. Of course, it is not cheap. We have to spend more than $120,000 US in order to actually start with the car, social equity concerns, and of course, we require a proper city infrastructure planning if you really want the car to move. So I will be telling you in next of the slides that why India is not ready to actually adopt autonomous technology, why it is not ready, and why we should, what we should do in order to make India ready by next 4 to 5 years. That's why I'm telling everybody 2021 to 2025, it's a crucial breakthrough for the mankind in every space. When convergence is taken seriously, real-time critical applications are being implemented, research is actually being utilized at the real time. So that's the answer, that we have to keep a focus on what we are doing and what we need to bridge up and what the problems we need to solve. So policymakers have given the SDV, so benefits for both individual and society. So you can say that with autonomous vehicles, we have fewer accidents, we have the less congestion, better parking facility, lesser cars will be used for traveling, cheaper mobility, best convenience, and of course, the elderly people or people like me, I'm saying you openly, I don't know how to drive a car. I don't know. And even if I buy the car, it will be like a dummy toy for me. I use motorbikes today because I'm in Vietnam. Over here, the cars are very less. Of course, it is very less because people are very vigilant of the pollution and traffic congestions. We use motorbikes. But still, few people have the cars. But still, if I want to buy a car, I would like to invest in autonomous vehicles because I don't want to learn driving. So Americans expect, now this is the most important data that I've given in front of you, and you can see that there is not even a big balance, and still you can't say that this data is actually reliable, that I can take some decision on this basis. Like a kaun banega crorepati, when some of the audience say 33, some say 26, some say 34, and some say 25. So this is not a, you can say the audience can get, the person can get confused on the hot seat. So similarly, it is a data that really it is not going to take a good decision. So the question was that how the Americans expect that driverless cars will be common in 10 years. So the most important answer was 6 to 10 years. But of course, I would like to expect that autonomous car, if you really want to see that it should run in the city, because the city planning has to be done and lots of technologies need to be implemented. So I say that maximum by 2032. So don't 2021, we still require 11 more years in order to make this car operational as per the city planning and infrastructure. So most of the concerns about the self-driving cars, some people say that won't feel safe. Some people say won't be control over the time. Driving is pleasure, mixed traffic, sometimes the privacy. But still, let me tell you everybody that all these problems are getting solved. 2015 was a year when it actually started. 2018, we got some improvements. 2020, high-end improvements and even improvement in research. 2021, we take it to the next level to high and full automation. So that's the reason, everybody, that the partial automation has already gone. Now we are coming towards high and full automation. That's why we have the level 3. Now we are working towards level 4 and level 5. So consumer availability, and you can see the data is in front of you. Some people say 6 to 10 years, some people say 3 to 5 years. But still, as a scientist, I would like to tell you that I believe that by 2032, the whole of the world will be actually ready to adopt this technology. But still, we have to wait for more research. We have to wait for more improvements. And of course, city infrastructure planning. Because I will be telling you next of the slides that it is not easy to run a car. Lots of infrastructure and lots of investments of money is required. So let us start with the most important technology today. This was the foundation. Now I will be telling you what about the imaging, sensors, and systems. So we will be discussing about autonomous cars with their technology in depth manner. Now I will make this lecture interesting and you will learn a lot from this now. Now see this, everybody. Now don't consider it as an ordinary car. It's a smart car, or you can say a future, or you can say a cyber physical system. So today I'm not giving the lecture on industry 4.0. So cyber physical system means that a system that is actually connected over the internet, and most of the decisions and operational capabilities are happening over the cloud, which means most of the things in the real time will be happening towards cloud, and the vehicle is working using that cloud operation capabilities in the real time. Now see this, if you really want the car to see, because we need to have the car, we don't have the eyes, because a driver has the eyes, but vehicle don't have the eyes. But for that eyes, we have to improve in imaging sensors. So you can say that we have different types of radar. Lidar is there, but let me talk about radar. Radar is actually known as the eyes for the car. So short range radar in order to front and rear parking, how to park from the front, rear parking. Long range radar, to detect the vehicles on the road and to see what distance we need to maintain for the safety. Visible cameras. And let me tell you, ladies and gentlemen, many people get confused that, okay, Sony is working, maybe Panasonic is working. There is only one company in the planet that has the capability to make this type of sensors. That is also known as the number one company for make the cameras. So don't consider Canon, Nikon or Panasonic. I'm not talking of these consumer durable cameras. I'm talking of professional and real-time operational cameras like we use in Discovery or cricket matches or other things, that the company is known as Red. So Red is the one technology, is a company that is actually investing 3D cameras, night vision, of course, lidar and ultrasound. So you can say that this car is actually connected with lots of imaging and lots of thermal imaging cameras. But in the near future, we will have the hyperspectral cameras that will actually go for more in depth, and even the cameras can see better in, you can say, bad weathers, rainfall seasons, and even snowfall. So this is the environmental conditions that we have to research, and even me and my team is also working to find the problems when there is a heavy rain, so that vehicles can take the decision. Now, these are the sensors, everybody, that is actually for vehicle computer system. So adaptive cruise control, traffic sign recognition, surround view, parking assistance. So in every sensor, we have artificial intelligence and computer vision that is actually learning in the real time. So this car is also marvel for deep learning, where we don't have to program explicitly, but the car is actually known as learning system, which means the more you rotate the car in the road, more better it is becoming and familiar with the conditions, and more better it is making its software brain better and fully operational and flexible for dynamic changing environment in real time. So autonomous vehicles, second generation vision system. So till date, I'm going to show you this one, but third vision system, I'm sorry, I don't have the permission because again, it will be conflict of interest. So for the second generation system, we have the camera platform, which is going for viewing, behavior discussion, control, host manager, and all the situations are being analyzed. Now you will be stunned to say, everybody, that what if I tell you that suppose if on a road accident happens, we as a human being, we see the situation and then we make the decision. So what about the car? Car doesn't know it. So for that, we need to make the car reinforce learning and deep learning in order to improve that. So autonomous vehicles, you can see that we have the AV specific redundant hardware system. So we have the 14x cameras, till date 14x zoom, 3x radar systems, 5x radar system for 3D dimensional view of the world, 8x radars for detecting the vehicles and velocities, and 10x ultra long range radars. And let me tell you, everybody, that every radar, every camera, they require to be connected to the internet in real time, because why? What they are seeing is actually being processed in real time with their cameras and deep learning algorithms, which means we have to be connected 110%. I will be telling you what other companies are doing for connectivity. Connectivity is most important. So you can see that this is the market that actually started. So you can say that it is not a very old technology. It's a very recent technology. And if you ask me that, sir, what is the age of autonomous vehicles? I will say only 5 years. It just started from 5 years back, 2016. That's all. And today is 2021. But still you can see that how much improvement we have made in the last 5 to 6 years. So lidar market, we started from 300 million US dollars, but now the lidar market is above 1.4 billion US dollars. And similarly, you can say lots of startup companies, commercial taxis, and everybody, they're using lidar technology and sensors as the backbone for the future of automotive. So these are the main companies or the major players. And you can see that right now, the Velodyne, the Oster, and even Panasonic, Pioneer, Continentals, and even RoboSense, they are doing lots of good work in terms of lidar and other things. Let me tell you, ladies and gentlemen, that even Bosch is a company that actually stopped their operations from China because of this pandemic and worst policies by the government. But now they've entered in Vietnam, and they're doing wonderfully well in IoT and even in lidar technology. I visited them 2 months back, and believe me, their team is excellent. That has come from South Korea, team of Vietnam, and I will be soon joining them as a visiting consultant. So radar's long-term evolution, and you can see that we started from level 1 when we just have object detection in 2014. That's why I'm saying you, it's just only 5 years back. So in 2016, that was an improvement with object detection and better features. 2018, when we have high resolution and target separation, that, okay, sir, this is the vehicle, this is the animal, this is the traffic sign, this is rain, this is left, this is right, what we have to do. But level 4, we actually improved, but I don't say that it has been done, but it will be improved by 2022 now with 3D detection. But by 2030, when the car will have the level 5, which has the 360-degree object recognitions. So these are the application of MEMS in automobiles when we have the different types of sensors, accelerometers, micro sensors, IR sensors, pressure sensors. We have everything everywhere. So this car is actually known as an engineering marvel with computer science, electromechanical systems. Everything that you can expect of technology of today is in the part of the car of today. So the sensors market, this is where I'm doing my research. I will not tell you much about my research, but you can see my research on Google Scholar, what I'm doing. I'm doing work on, I would like to tell you, security and improved computer vision system. That's all. I can just say only this thing. So 2023, you can say that in next 2 years, we can see that this market can even touch 20.4 billion US dollars. So that's the reason, everybody, if you're doing your PhD, ask yourself that rather than you play with simulators of MATLAB or NS2 or NS3, just try to work on the real-time critical application. You will earn a lot, and this will make credibility for your research. So number one company for automotive MEMS and sensors that I've already told you for IoT also. Vietnam is an IoT and blockchain country, and I'm having my lab of IoT only. So we work with Bosch, we work with Denso, Panasonic, Sonesta, Sony, and even Semtel Technology. So these are the companies that are actually doing wonderful work in MEMS and sensors. So now how the automation process started, you can see that the first important thing, now see this, don't look at here, just look at these 4 blocks. Now see this. Now the first thing that we actually require at the back end, everybody, that will be the remote data centers, or you can say the remote cloud computing servers that are actually going to do processing of the cars in the real time. And that's the reason I'm telling you that we don't require cloud computing, we require fog computing, edge computing with AI enabled hybrid clouds in order to make the vehicles to do the decisions in the real time. And after that, we have been connected with the localization, especially with GPS and sensor data. We have sensing that we have already discussed with the radar, LiDAR, imaging sensors, ultrasonic sensors and everything. And with the power of machine learning and AI, we have designed our own software brain in order to make the car to perform the action. That is whether it is brake, improve of the speed or tone down the speed. And of course, the car is able to supervise what is happening. So these are the 2 functionalities which require tons of infrastructure and planning that is to be done. And that's how I'm saying you that running the car in the real time, it is not easy. It requires much more critical infrastructure and better planning. Lots of problems are still there. We have to find the solution to that. So autonomous vehicles, you can see that developing the MVP when we have the self-driving vehicle brain, deep simulation capability, interactive interface, sensors, customer support, and of course, the total cost optimization. So let me tell you, everybody, that all these components, they have to integrate it together. Whatever you think of the mankind of today, everybody, mankind, everything, it is actually will be the part of these autonomous vehicles. So this is the self-driving software brain, and you can see that these are most of the features that will be informed in the AI chips that will be handled in the car, and this will be able to perform with outstanding quality, performance, cost, and even they can perform with second-tier domains. So localization, machine learning, behavioral control, networking, simulation, and testing driving. And believe me, today the neural networks are doing lots of work, deep learning neural network, and of course hybrid and cognitive learning. They are doing exceptionally well in order to improve the software brain, so that when it is improved for the real time, it is becoming better and better. South Korea is right now the #1 country in the world that has actually made a virtual smart city, a dummy city. And on that, lots of companies like Honda, Hyundai, Mercedes, Vameo, they are all coming together and they test their algorithms there. So this is a good project that you can do. And even you can work with a project grant called Korea Brain. And there are lots of projects with Indo-Korea also. And you can collaborate for this type of AI, and real-time applications can be autonomous vehicles. So tons of possibilities. Okay, so right now I would like to tell you that NVIDIA is one of the company that is having their own Jetson Nano. And of course, many people ask me, sir, how we can start the research? I will be telling you at the end of the session that how I'm doing, what infrastructure I'm having. So we trust NVIDIA Jetson Nano. And of course, we have the AI cameras like Raspberry Pi. And of course, we use a deep learning neural network with Python and R language in order to improve the vision capabilities. So I work on computer vision capabilities. So platform providers could be the big winners, and of course, the cloud computing will be everywhere. And like you can say that Oracle Cloud, IBM Cloud, and of course Amazon Web Services, they will be the big players, because in the future everything will be actually bridged on the cloud, and they will be the platform providers. So what if I tell you that Amazon is running a cloud and it is actually running for your car? How this cloud is actually giving the decisions for you, how the data is being floating from your car to the GPS and even to other activities. It will be done with Amazon Web Services or Azure or even Google Cloud. So these cloud computing will be the great platform winners in the near future. So if you talk of the number one company for autonomous driving vehicles, everybody, it is not even GM, it is not even Volkswagen, it is not even Ford. The number one company in the planet is Vimeo. I know many people have not listened to this company, but it's the most important company. And you can see everybody is a contender. But the challenges are computer companies like Apple, Tesla, and Voyage. Of course, Tesla is improving. Of course, we need the Tesla, but still Tesla needs to be improved in terms of privacy and of course, with smart automation capabilities using hybrid learning. Now we will talk of big data, everybody. Now, of course, if you talk of sensors, if you talk of any IoT project, we have tons of data. Now imagine smart cities, everybody. Let me tell you, ladies and gentlemen, that if you're talking of IoT, most of the people gets confused that what is the wireless standard. And many people say, let's on Bluetooth, let's on Wi-Fi. This is known as short range connectivity with limited number of devices. But IoT, I'm not talking of limited devices. I'm talking of a bigger project when we have 7 to 10 million sensors and they're actually working in real time, giving you the data. And for that type of accommodation, you can't trust the 3GPP standards like 2G, 4G, or even your Wi-Fi, Bluetooth, or even your Zigbee. I'm talking of non-3GPP when we talk of 5G+. We talk of 6G when we talk of Sigfox, the LoRa communication. So that type of communication and that type of sensors, they require lots of data that will be generated at the real time. I will be telling you in the next slide that how much data one car can even generate, and our simulation has even tested that for driving the car in just a normal traffic from 1 kilometer. 1 kilometer can even require more than I'm saying you, it requires 56 Mbps of connection, and of course more than 20 to 30 GB of data will be downloaded. Now imagine if you take a car. Now imagine if you take the car on the highway, how much data is being pulled up. So you can say that car is having onboard security. Now today we use blockchain. So we have the consumer devices integration and of course the back-to-back cloud that is known as car to cloud. So that is the reason we have the direct connectivity with the cloud computing systems. And these cloud computing systems will be confirming for everything, whether it is traffic information, whether it is a signboard, pedestrian detection, software updates, security, or payment systems, everything will be done on cloud. So connected car services, you can see the live agent assistance, vehicle control, communication, and infotainment apps. And this is the answer, everybody. And just imagine and just do some mathematics that how much data will be required per second. Now, is India ready for this type of connectivity? When sometimes when I call to my friends' homes, and sometimes they always say, sir, let me come outside of my home, the connectivity is not there. Even the WhatsApp sometimes give the call drop features or call not connecting. So you can see that cameras, they require 20 to 40 MB per second. So imagine if we have 30 to 40 cameras, how much MB per second is required to be downloaded? Radar, sonar, the GPS, and LiDAR. So this is just the infrastructure. But if you talk of the cloud computing, if you talk of the blockchain connectivity, the things gets more complex. So the vehicle is actually known as the intersection of analytics, the big data, the connectivity, and of course, mobility. So what is analytics? The AI to perform the decisions, connectivity, the 5G plus and 6G. So non-3GPP standard, and mobility, of course, cloud computing, which is known as the edge AI or smart AI clouds. So monetizing the mobility service, you can see that we have the consumer preferences in terms of consumer needs. All the things are in front of you, and multimodal solutions using car sharing, smart parking, drive on demand, recharging, and of course, pay as per drive. So everything can be monetized. The only thing is we have to rely on sensor data. We have to rely on streaming technology. And of course, the mobility situation depends on the transportation of the vehicles. And let me tell you, if you talk of congested cities like Mumbai, Bangalore, or Delhi, then this type of cars will not be operational because this type of car requires not very high congested traffics. So autonomous vehicles, that becomes the world largest Internet of Things platform. I'm talking of millions of sensors where everything is live, operational. We have the e-commerce, electricity, forecasting, deep learning, AI, and of course, the travel protection, GPS sensors. Everything is integrated on one cyber physical system, that is your autonomous vehicle. So you can see that I have already told you that the future of cloud is only the edge AI. So today, if you talk of cloudy edge, when we have edge and cloud computing working together with fog computing, and of course, in the near future, we have Industry 5.0. Of course, we have smart grids, smart hospitals, the chatbots, and automation. So that becomes edgier. But if you talk of the future, when everything will be automated, when we go for robotics, when we go for like autonomous vehicles, smart cities, connectivity, it becomes the edgiest. And autonomous vehicles, big potential, big data solution. And this is the answer, everybody, you can see. And soon our paper will be there. One paper has already been published in transactions for TBT, and one paper will be soon published in FGCS. So my all papers of autonomous vehicles are only with more than 5 impact factor. So you can see that this is a connectivited car, and they have and they are getting the data traffic. So data traffic should be with a high throughput, and it should have no latency. I will be telling you after some slides. So it should be no latency. So which means that 4G and 5G will not be there. 5G plus and 6G, these are the standards that you can rely on that. So they will be having the continuous access, and we have the network access, which means the smart edge computing in the real time. And of course, it will be having the flexible topology with smart computers, that is the vehicle-to-vehicular communication, intelligent driving assistance, high definition maps, the GPS. And they will be bridged together at the back end, which is known as the powerful cloud in the world. So these are the connected car platforms that you can see right now. And almost everybody in the world, including Apple, Microsoft, Google, Vimeo, Panasonic, Bosch, I've given you the companies, everybody is working on that. Now we talk of my favorite topic, and this is the topic that I'm actually working in real time, that is known as wireless connectivity and communications. So before I proceed, everybody, I would like to tell you that I'm the first person in the planet that has actually done the Australian patent on my own LoRa communication, my own LoRa protocol, and my own LoRa digital signal processing system, which means I have my own ecosystem of LoRa communication, and it is only patented by 2 companies in the world. One is Samtel, that actually invented LoRa, but their LoRa is very expensive. Texas Instruments, they improved, but it is not reliable. But our LoRa communication system is also integrated with blockchain system. So the most advanced LoRa communication standard that I think can be adapted in the future with car companies for communication among the vehicles to go for sensor reading and other things will be adapted from my technology. And we are improving like anything with that. So this is the map, first of all, in front of you. So this is known as the 5G plus. I'm not talking of 5G now. I'm talking of 5G plus. When we have unlicensed 5.9 gigahertz ITS frequency bands, and that is actually for next generation dedicated short range communication. So short range communication is very important, and you can see only one standard is there, 802.11p. So if you are interested to write a review paper with me for this thing, you are most welcome. I'm looking for a good collaborator for that. And right now, if you talk of the #1 company for communications that is actually going for 5G antennas and design and development, it is not Qualcomm, it is not even that is AT&T, it is Nokia. After that, Samsung, and after that, AT&T, they are doing wonderful work in antenna design and development. So this is the autonomous dedicated short range communication technology over vehicle to X. Vehicle to X means vehicle is connected to everything. Vehicle to vehicle, vehicle to device, vehicle to pedestrian, vehicle to home, vehicle to grid. We are working on everything. That is the answer, everybody. That's the answer to the modern warfare. So triple RTX technology, and this is one of the technology that is actually going for real-time global tracking system. So don't think that tomorrow is the age for GPS or AGPS or GLONASS. It is the age for triple RTX, when we have precision accuracy calculations. So imagine if a car is working, it can only trust the GPS system. I'm a drone pilot, and let me tell you, when I fly the drone, almost 24 satellites get connected. And only then I can make my drone to go at the larger distance, and it can come return to home. Otherwise, it cannot return to home without GPS. And that's the GPS technology that is enabling to have pinpoint location and other system adjustments. And that's the reason, everybody, when you just put your drone in the air and you just put return to home, the drone is autonomously taking the decisions with using GPS as a guiding service. But we want that in the near future, we use a triple RTX so that we can run the drones to larger distances, I can say. So direct communication for active safety, and you can see that the vehicle is taking the decisions. Vehicle can detect as a left turn, right turn, brake the vehicles, detect the animals, pedestrians. They take the decisions as per their NLOS performance with near line of sight performance. So this is the standards that I would like to tell you, that we started with 1G, 2G, 4G, 5G, and today we are all working on 6G also. And 6G, Huawei is also there, that is working. So the number one country in the world that is actually working for communication standards is Taiwan and South Korea. So the 5G is very important because it has a high bandwidth, no latency, and better throughput. That is the reason that we can only trust on 5G for this type of vehicles. Now imagine, give a question to yourself, when India can become a 5G country? You will all say not even more than next 6 years. And of course, if you add 6 years, it is 2027. So if in 2027, if only 30% of country is connected, now imagine how much cities will be actually capable to put that vehicle. And how much time will it take by India to put vehicles as part of smart cities? So you will imagine that by 2045 or maybe 2050. So LTE, the advanced LTE, again, that's a revolution with autonomous vehicles for ubiquitous LTE, 5G, NRM waves. And of course, I will not discuss much today because I'm not giving the lecture of wireless communications. I will stick towards autonomous vehicles. So the wireless edge will be the potential for that. So why we use 5G? Because we can have large number of connections. So imagine, everybody, if you talk of the Tokyo Olympics, which are already cancelled now, but I'm very, you can say, annoyed that because of this pandemic world, we are getting lots of technology that we have seen, we have observed in last year and even this year, but we are away from them. So 5G is a number of connections, because if you talk of Tokyo Olympics, many people, million people are working, are sitting in one ground in a particular position. You can't trust 4G there. Enhanced broadband, and of course, less than 1 millisecond radio latency. So latency, error rate, attenuation, it's almost gone. So we have the multiple paths for IoT connectivity when we talk of the LoRa communication, and that is where I'm working. I'm the inventor of my own LoRa with wireless PAN, and of course we can go towards Sigfox, and of course the future standards I'm telling you today, that is known as Z-Wave, and even towards NB-IoT. So NB-IoT is one of the good platform, and soon my one paper will be published in IEEE Communication Service with 23 impact factor. So you can see my Google Scholar once it is published. So IoT connection technology, and this is where I would like to inform all of you that this is the future if you really want to work in smart city communication network, when we have millions of sensors, millions of devices, gateways, and of course, we require unlicensed spectrum, we require cognitive radio ad hoc networks for implementation, IoT, and smart Internet of Everything. So for that, we have Sigfox, LoRa, Telensna, on-ramp, and even 802.22. Now, I will be happy to inform you that I am now making my own Sigfox also. So if I can make my own Sigfox, maybe I will be the first person in the world that is actually patenting Sigfox. Right now, there is no patent for Sigfox. Now let us talk of security and vulnerabilities, and you can see that the car is actually a cyber physical system connected with whole of the world. So of course it is vulnerable to attacks. Like you have seen in Fast and Furious picture that lots of cars were actually moving without anything, and hackers can even control your controls of the car. Yes, it can happen, but of course we have the solution via blockchain, and blockchain cannot be broken unless or until you don't have a quantum computer. That is not going to happen in next 15 to 20 years. So this is the intra-vehicle networking, where we can have the LIN, that is low-cost bus for body applications with UART interface. And of course, the networking standards, you can see the local internet network, controller area network, CAN-FD, SCAN-PN, FlexRay, and Ethernet. So these are the main automotive networking standards that we have. And of course, we need to have the 4-layer security of the car, when the layer 1 is known as secure interface, when we have secure machine-to-machine authentication. Of course, today we have the smart key lockers. Today we use RFID technology, and layer 2 is known as secure gateway, that how the data will be connected towards cloud so that nobody can have man in middle attack or denial of service attack. Otherwise, it would be a problem. The third will be the secure network. Of course, it will be a secure network from edge cloud, from big data analytics to the high-end cloud. And of course, we have the secure processing using blockchain. So blockchain is one of the area that you can do your research, and real-time critical applications can be your autonomous transportation. Okay. So this is one of the infrastructure that I would like to tell you. You can just go to this company website, trillium.co.jp. It's a Japanese company. One of my friends is also there. So they also tell me sometimes about this thing, that we have a comprehensive solution and we don't want to build up any idea system. We want to build up a comprehensive gateway so that all the attacks can be filtered. And believe me, everybody, that you can't trust these antiviruses or other things. You have to trust the deep learning, and of course with blockchain protection. So only thing is that we have the advanced secure system that will be impossible to hack. Now let us talk of some examples now. So the first example in front of you is Google X 2014, but still it is under the progress. Here is Uber, and that is the reason that I'm very annoyed with the COVID pandemic, that last year it would have been started with Singapore with flying cars, but now we will have to wait by 2022 to get the flying car started as a app, which means you just open your mobile phone, order a flying car, and the car will come to near your home. You just have to sit in the car, fly in the car, and reach your destination. It will happen in next 1 or 2 years. Okay, so this is the Tesla Model 3 structure, and you can see that it is having the aerodynamic design, and of course Tesla is working hard towards autonomous revolution. And here is, you can see the Tesla full driving control with level 3 to level 4 automation, when controls are there and some of the controls can be shifted towards the car software brain in order to take explicit decisions without being programmed, and everything is being programmed. You can see that this is the object detection that you will see today in terms of OpenCV and YOLO version 5. So you can work on these things. I'm working on YOLO version 5. So if anybody wants to collaborate with me on computer vision, you are most welcome. So after that, you can see this one, the Ron Group, and you can see the most futuristic car and the most futuristic vehicle in the world. And this is the Volvo 320C concept, and you can see that the person is even sleeping, the person is having the drinks, and there is no control in the car. Everything will be controlled using the software brain. So this is the one, you can see that from 2019, of course, we have the EV vehicles today, and India is going to soon join the race with Tata vehicles. And you can see that the race actually started from 2019 when we have Audi e-tron, 2020 when we have Porsche Taycan. And this is my dream to buy, everybody, maybe in next 2 years, that is Audi A SUV. I want to buy my Audi. And Volkswagens, and of course in 2024, the Volkswagens, Tesla, they will take over. And this is the Volkswagen unveils self-driving electronic bus. You can see almost no controls. And this is what you can say, that you can customize your own driving code with your own hardware stack. In the future, you can have your own programming skills. You can make your own vehicle. And maybe in the future, like we can see the discovery programs, when we have the junkyard wars, we can have these autonomous junkyard wars also. And this is known as a Toyota Mobility Service Vision, which you can see that it can go for pizza delivery, your courier delivery, and of course at the airport, these are known as these things. So I don't know how many people have gone to Singapore. If you have not been to Singapore, go to Singapore. This is the country that actually is adopting autonomous technology. When you go to Singapore airport, you can see there is a tram that can take you from local terminal to terminal 3. I've been there, and there is no driver in that, autonomous. And of course, they are using digital twin also. And this is what suits me, everybody, the company timeliness. And you can see that all of the companies from BMW, Tesla, Audi, Toyota, they are all working from 2020 onwards on fully autonomous vehicles. And 2021, you can see autonomous shuttle also. Of course, it should be there because it is actually having the requirement. And this is where you can see that the future FedEx couriers will be giving that delivery to you. So if you order something on Amazon, that the local Amazon office will be just putting that box in that robot, and you just have the QR code in order to open that, authenticate that, make the money, and the drone will, and this autonomous vehicle will give you the delivery of your packet. And this is FedEx. Remove the courier walas when the letters and your telegrams will be coming with the robots only. And this is Nikola company, and this is working very great in terms of military vehicles and other things. And this is what I want that India should now focus seriously, because of course we have used drones and we have using swarm drone technology. But now rather than to have the laser guided technology, we need to have the multispectral cloaking with the autonomous driving. So in the military, in the future, military is one of the area that is going to have the boom in the world for the autonomous revolution. And this is a Sea Hunter autonomous warship where it can detect the mines, underwater submarines, other things, and it could be the role model for our country to keep the Bay of Bengal and Arabian Sea secure in the praise of other enemy countries. And this is the truck that you can see with Nikola 1, and of course the Tesla semi-electric truck which has been launched last year. And this is Vimeo is doing lots of things in terms of self-driving trucks. So if you get a question anytime that which is the #1 company for autonomous cars, the answer is Vimeo. So this is the intelligent transportation with IoT, and you can see that we have the 4 layers. The #1 layer is known as infrastructure at the back end, when we have only cloud computing and the GPS technology. The service layer, when we have the services that like in-car infotainment services, the security, the connectivity, and of course the communication layer, when we have the 5G and we can only trust the LoRa communication with sensors, and of course the sensing layer, when all these sensors will be grouped together and they're working in real time. So let me tell you everybody, so how the vehicle will work, the sensors will work and take the decisions using this thing, that is the communication and providing the services, and of course at the end we have the infrastructure. So this is the Boring Company, everybody, and you can see that Tesla has recently seen that Elon Musk is now in the future with Hyperloop. So maybe in the future that India should adopt Hyperloop technology, because it is actually required, because we all know what is the situation of metro lines in Delhi and in other parts of the country. We have large population. Hyperloop could be the solution for that. So this is the Boring Company that is actually making the vehicle. So you don't have to take the vehicle like different things. So you can just put your vehicle over it, and this car will autonomously drive for you. And I just want to wind up the lecture with this thing. So the future of energy will be the Energy Cloud 4.0, when we have everything connected with smart city, Internet of Energy, neural grids, and of course, Internet of Vehicles. So IOV is one of the area that you must do research on that. Must do research. And I think so this much is okay for us. Okay. So this was my lecture #1, in which I have discussed with regard to autonomous revolution. Now, if anybody has any question with regard to autonomous revolution or drones or any other thing, please, you are most welcome to give me the queries. I would be happy to support you with all of your questions. And I hope everybody has enjoyed. Okay, so I got a question. I think everybody is praising the lecture. Thank you so much. So I got a question. Yes, from Mr. Piyush Lotia. At present in consumer industry, mobile phones are most complicated device, but autonomous vehicle is the most complicated and integrated system, I guess. Of course, Mr. Piyush, that when we started with new technology, the things are complicated, but still you can see that how. Now, let me give you an example. When smartphones started, what were they? Now, imagine if you talk of HTC company, which actually laid the foundation for smartphones. Today, where is HTC? HTC is no longer existing. Okay. Now, see how Apple has revolutionized from iPhone 5 to iPhone 12. Believe me, from iPhone 8 to iPhone 12, that technology is even a remarkable example that where we are going. And of course, from Samsung Galaxy S16 to S21, even it's a pioneer device. So you can say that the things will not become complex, things become advanced. Now imagine then that was a time when only mobile phones were used for phones and other things. But today you will be stunned to note that I got a survey, even I'm writing one research paper on that, that is the booming utilization of mobile phones in one day, what we are using. And believe me, the people are saying we use mobile phones rather than for talking, we use it for messenger and even for that is the cameras, which means now your smartphone is like a camera device. Now people even don't listen to songs, people don't call, they use mostly of the camera. That's why the calling features and the camera features are becoming advanced. Have you seen that we have done anything better in terms of calling? No, nothing. We have just got 4G, VoLT, now we have 5G and we have the 5G plus. So improvement is going towards technology, sensors and features and functionalities. That's the answer. But of course, with autonomous vehicles, the things are getting better. I don't say the things are the best right now. Things are getting better because why? We have to improve AI. Because let me tell you, if you talk of technology today, when we don't have much in Python, we don't have much towards libraries, then when AI was only a subject. But today, AI, without AI, I can't imagine anything that can operate functional. So there was a machine learning, and I will be discussing machine learning in digital twins, but my dream is to take it to the deep learning. Okay, I will be telling you what I'm working. So for autonomous vehicles, what I'm working is to put like, I have a, let me show you, okay. So everybody, I would like to share one of the important thing. I would because this car is in my lab right now. So I'm using this model truck, everybody, Stampede, and over there, because this is one of the best car model. So I'm improving this model with the AI chip, in which I'm integrating IoT and other sensors, and I'm using Raspberry Pi camera with Jetson Nano. And believe me, we are trying not only with this remote control vehicles, we are actually trying with how this car can even take complex decisions, how we can make our track complex, and how this car can take the speed up, speed down. And believe me, our track performance is now improving with AI. And we are using Python libraries, we are using TensorFlow, we are using OpenCV, we are using YOLO version 5, we are using NVIDIA Jetson technology, we are using everything in our research.
Thank you, sir.
Yeah. Any other question? Everybody, if anybody wants to interact with me, they can unmute themselves, they can interact. I love interaction.
Okay, any other question or query from any participant?
Sir, we would like to have this PPT and the video lecture as well, because
sir, I can sir can give you the video lecture, but PPT, I'm sorry, because it contains confidential information, and we are improving this PPT because this has been remarkable work for us. So we cannot share the PPT because of conflict of interest. We can't share.
okay.
Yeah. But I will share one of my PPT of the next session, that is digital twin, because it's a new technology. I would like everybody to work on that technology.
That's why I asked for that. So because of a lot of
what I can support you for the best, I will be providing you.
Okay.
Okay, any other question from participants? So thank you very much, sir, for this wonderful session. That was really a very interesting, and we have the various new things from your lecture, and definitely this will help all the participants to explore the area which are interested, those are interested in this particular field. So thank you very much for this session, sir.
Yeah, thank you. Next session will be even more informative when we discuss the digital twins. When I will be telling you that can we make that machine that can perform accurate operation, even that doctor cannot do, the machine can perform.
Okay, great, sir. So there's a little there is a short break. We start our second session, next session at 2:10. So participants, if you want to take a break, you can take a short break for 10 minutes. We start the next
sir,
session.
please inform me, because I'm sitting over here only, and I will be starting in 1 minute. I just need my PPT ready for that.
Sure.
And Nitin sir, please kindly give me one email. I think so you have my email. I will be sharing my email in the chat box after the session. So you can give me one email that, sir, please provide me the presentation of digital twin, because I'm on my MacBook right now. So I will be immediately replying to the email, and you can share the presentation today to the participants.
Sure, sir. Sure.
Yeah, definitely. I can provide of digital twin. I'm sorry, I cannot provide this one.
Okay, sir.